In this video we'll be looking at the topic of isomerism. So the aims of this video are to be able to define structural isomerism, to name and draw position isomers, to name and draw chain isomers, and to name and draw functional group isomers. So these are the three types of structural isomers that you need to know for Chem 1. So firstly, defining structural isomerism, there is a distinct 2-mark answer for this, and that is that structural isomers have the same molecular formula for 1 mark and different structural formula. So you remember those two parts of the definition of a structural isomer, then you'll get both marks. So the first type of isomerism is position isomers. So I'm going to give you an example of this. So here is a halalkane. I'm going to draw all the different bits. So we've got 5 carbons and we've got a chlorine there on the second carbon. So this is called 2-chloropentane because the longest chain is 5 carbons and the chlorine's on the second carbon. So a position isomer is basically where the functional group or the halogen in this case moves position along a chain. So a position isomer of this compound would just be the chlorine moving, for example, to the third carbon in the chain. So if I just draw 3-chloropentane, then that will be a position isomer of 2-chloropentane. Now you've got to be careful with position isomers, because if I move the chlorine to this carbon instead, then actually that will be the same compound, because all that will be doing is flipping this compound on around this carbon here. You could put the chlorine on the first carbon, that would be another position isomer of this compound, that would be called 1-chloropentane. Chain isomers are where you get branching off a main chain. So again, if I use the pentane as an example, 5 carbons, that will just be the straight chain isomer of pentane. But you can also get other isomers that have 5 carbons in, but only have, for example, 4 carbons in the longest chain. So, for example, you could have this compound here, which is 2-methylbutane. So that would be an example of a chain isomer of pentane. So here the longest chain is there, and the methyl group is on the second carbon. So this is called 2-methylbutane, whereas this one is pentane here. But you can see they both have the same molecular formula of C5H12, but they have different structural formulae in that they have different structures. Now you do have to be careful sometimes when drawing chain isomers. So if we have pentane again, and make sure we draw the hydrogens in. It's good practice to draw the hydrogens in an exam. Now a common mistake is to say that is to draw 4 carbons to prepare yourself for doing a chain isomer, and then saying, well, I'm going to put a methyl group on the first carbon. Now that is incorrect, because you can see that here the longest carbon chain is still 5 carbons. We've just moved this carbon around the corner here. This longest carbon chain is still 5, so this is still pentane. And you've got to be careful that you don't make that mistake in an exam. So the last type of structural isomerism is functional group isomerism. And this is where basically 2 compounds have the same molecular formula, but they have different functional groups. So an example would be, for example, an alcohol such as ethanol, which has 2 carbons, 1 oxygen, and 6 hydrogens, so C2 H6O, and this compound here, which has the functional group instead of a COC, and that's an ether functional group. So this has the same molecular formula again, has 2 carbons, 6 hydrogens and 1 oxygen, but it has a different functional group, has an ether functional group rather than an alcohol functional group. One to look out for is the functional group isomer of an alkene, for example, pentene. I'm just drawing pentene. Now sometimes it's quite difficult to visualise what the functional group isomer of this would be. But basically the functional group isomer would be getting rid of this double bond, the alkene functional group, and the only way to do that is to form a ring instead. So cyclopentane would be a functional group isomer of pentene, and that's one that sometimes crops up in an exam. If you're having any trouble with isomerism, then please come and find me in revision sessions.